Whiz Potter. Who is he? How did he get that scar? And where are his parents? I don't know the answer to any of these because I cannot read. However, I did watch that one scene with the sorting hat, and I thought, yeah, I could make that. So I'm gonna make that. To start off, I looked at a couple of videos of like different animatronic sorting hats, and I didn't actually see anything that moved exactly the way that I wanted, and that meant that I had to build this completely from scratch. To be honest, I don't have much of a plan. I'll show you the drawing I do have. So yeah, here's the drawing. It's not a lot, and that is what concerns me, but once I figure out like what it'll look like, how I'll build it, what it'll be made out of, what the design will be, and how to put it together, it'll be done. It's almost there. Okay, so I locked in, I got designing, and this is what I came up with. So here's the initial design. What is this? What is this guy doing? This is way too small to see. Here, hold on. Enhance. See, there we go. Now you can see it. Let's go through this design. This is a metal rod which holds all the pieces. Think of it like a spine, but instead of a person, it's a hat. And then these little blue things are servos, which are like little motors that can move really specifically to make the hat move. You'll see. And then this is the mouth plate, which is gonna move to open the mouth. This is Jonathan. And this rod is to actuate the eyebrows. It's all built upon this base. And although it may not look like much now, it will all look much better later, probably, I hope. And it's time to get started. First, we're gonna build the base. Okay, so I need to cut this piece of wood. And due to space limitations, I only have this little workbench. So I think it'd be a little bit dangerous if I were to cut the whole thing just on this. But luckily it expands, so. Boom, just like that, bigger workbench. We're safe now. Some of these edges I cut when I was like 12, so they're not very straight. So I'm like using the square on like something that's not square. We got our screw and our pencil, makeshift compass. And that's a circle. I've made the base, but now we need to make the thing that holds all the stuff. So we gotta cut this rod down. Hey, where's my saw? Oh, here it is. Oh my gosh, okay. Okay. All right, so this is what I have for the robot so far. Really what it is just a mouth. So the top plate stays still and the bottom plate is on a servo, which is going through an ESP32 using this joystick. You might notice that it's kind of jittery when it moves. I think it'll work for what I need, but if it's like too jittery, I do have plans. But what do you think? Do you think it's good?
No, estos motores baratos me están dando un dolor eterno.
Okay, fine, I'll fix it. Let me introduce you to Hat 2.0. Improvement number 1, I added eyebrows. So now the hat can move its eyebrows. Improvement number 2, I used mechanical advantage to make the mouth move more slowly. But Will, what does that mean? I'm gonna tell you, okay? I'm gonna tell you right now, just be patient. Okay, sorry. Because the servo I use to drive the mouth is kind of cheap, it can only move in so many steps. So in say 15 degrees, it only moves in 5-degree increments. This was bad because when the servo was attached to the mouth directly, it could really only open in like 3 stages, which meant that it moved way too fast, and that's what caused the jitteriness. However, when I used this bar, I gave it something called a mechanical advantage. A mechanical advantage is essentially just the multiplication of force by moving more distance. And if you've ever ridden a bike with multiple gears, you've experienced this. You can put the bike into a low gear, which means you have to pedal a lot to turn the wheel a little. However, that wheel then has more force behind it, allowing you to go uphill. Or you can put it into high gear, which means you pedal less to turn the wheel more, but the wheel has less force behind it. Mechanical advantage takes many forms. Imagine you have a metal rod that hinges on this side. It would be easier to lift the metal rod from here than it would be from here, because it requires more distance to lift it from here thus requiring less force. The same thing is happening with the hat. I forced the servo to lift the mouth closer to the end rather than very close to the point of rotation. The mechanical advantage means that I can have the servo move, say 15 degrees, and the mouth would only move 5. So if I want the mouth to open up all the way, like 15 degrees, I would have the servo open up 45 degrees. In that 45 degrees, there's way more steps that I can control the mouth with, making the mouth's movement smoother. The other upside of giving the mouth a mechanical advantage is that the mouth then becomes stronger because the servo is moving more to have the mouth move less. All right, so I've added a different actuation system for the mouth so that it's less jittery, which means now the mouth runs much smoother. Wouldn't you agree?
Sí. Me siento mucho mejor ahora.
So the hat mechanism at this point is pretty much done, but keen viewers might have noticed that it doesn't actually have a skin, right? So it doesn't look like a hat. What I'm doing right now is bringing it to some people that happen to know a lot about this kind of thing so that they can actually put skin on the hat. Let me introduce you to Connor and Luke. Partners in crime, they'll be helping me with the outside of the hat. So, now that they're making the skin for the hat, I can actually start working on the rest of the electronics for it. And what I mean by that is a more permanent solution for the circuit. Right now, everything's on the breadboard, the little white rectangle. And the issue with that is that connections can come out of that over time. So I'm putting it on this, which is called a perf board. I'm soldering all of the pieces to the perf board so that they'll actually stay in place when I need to use it. Now I've actually made a design, which is this, and it's not too complicated. I think it'll get the job done. What was that? So, while Connor and Luke did the lame part, I was doing the cool part, spending 4 hours hunched over my desk inhaling fumes. So we got the batteries loaded in. If I flip this switch, the board should turn on. Oh, thank God. Oh my God, I'm done. I was not, in fact, done. But to understand why, you'll need to know 2 things. Thing 1 is that the servos operate only on 5 volts. And thing 2 is that the battery pack I was using gave out 6 volts, which was too much for the board and the servos. So I used this little thing called a buck converter to turn that 6 volts into 5 volts. Now, the board did turn on, but I knew that the servos absolutely needed 5 volts to work. So I decided to test the voltage coming out of the converter with a multimeter. I mean, obviously I knew it would say 5 volts, but wait, that doesn't say 5 volts. Why doesn't that say 5 volts? Well, what's wrong here? If you remember right, this thing called a buck converter is supposed to turn that 6 volts into 5 volts. So if 5 volts aren't being outputted, it must be this thing's fault. This one must be defective, which is really annoying because it'll take a while to replace.
Welp.
Welp indeed, Will. Welp indeed. So let me go through what it takes to replace one of these, okay? First, you have to use a box cutter to etch this little thing out so that you can break a little wire in the board. Then you have to solder these 2 pads together. And then you have to take the old converter out. So you have to use this wire stuff to suck up all the solder so that you can take it out. And in the process, I melted like everything else. So now it looks like a total mess. But eventually, I finally got the other buck converter in, and now we can test it to make sure that it's working properly.
Both of these are defective.
What? It's still not working. Okay, fine. All right, 2 defective parts. I'll just try another one, right?
I just want to get this board done, and it's late, but I think I'm frustrated and tired enough to keep going. We're gonna get another one. We're gonna try again. This is so stupid. Weird noises. That's part. It's listing the voltage out equivalent to the voltage in, which does not make sense. Not sure what else to say about that. At this point, I've gone through 3 of them. None of them have worked, and I am at a loss for why. And I feel like I might just have to deduce it to factory error because I've used these before. I could try this last one, but given that my failure rate is so far 100%, I'm not too confident. I'm gonna go for it anyways. Moment of truth. Are these all junk? Yes.
Now at this point you might be wondering, Will, if the first 3 didn't work, why did you even try a 4th? And I'll tell you why. I had another converter that did work in this situation, but it was one that I had always used for testing. So I had these wires soldered in here. And because the wires were soldered in, these little connection holes had already been blocked. So I wasn't able to put it in this board. That's why I kept trying them over and over, because I thought there was a chance they might work. So at this point, I've gone through 4 of these converters, and they are all not working right. So I guess I should just give up? Like, what is that? The saving grace. In my little box of electrical trinkets, I found one last converter that I had. This could actually work. The thing that finally saved this project. I'm not even sure that I would be able... What was that? That one didn't work either.
There's a weird buzzing and it is not working. Guys.
Now, in situations like these, we as humans often wonder who to place blame on. Was it my fault? Was it the factory that made its fault? And honestly, at this point, I'm still not sure. I think that the issue was I needed to provide more than 6 volts for it to be converted down to 5 volts, but the documentation didn't say anything like that. And in hindsight, after testing, I don't know, like 3 of these things, I should have known that the next 2 weren't going to work, but I had one that was working. So maybe that one was just like extra well made, like I don't know. So that piece of this issue still remains a mystery. But at least that was the only thing wrong with this board. Well, sometimes when life gives you lemons, it takes extra lemons and squeezes the juice into your eyes. Hence reason number 2 that it wasn't working. When you buy a microcontroller, which is a type of computer that I'm using to control the hat, it comes with one of these. Okay, this is called a pinout, and it describes what every pin on the board does. Now, this microcontroller has a couple of ground pins. I also have a button on the back of the hat that I use to test it. Okay, I'll save you from the explanation. Basically, for the button to work, this ground pin needed to work as well. But this ground doesn't actually work. It doesn't function as a ground. It doesn't function as anything. And I know that because when I tried to connect this pin to this ground, it didn't do anything. And when I tried to connect this pin to another ground, it worked. So that is 100% factory error. You cannot change my mind on that. And it pisses me off. That's all. And so, as I often do in situations like this, I went on a walk. But this walk was a little longer than most, because where I usually stop, I just kept going. And eventually I realized that I might be lost. Sorry, I don't have a lot of time for questions right now. I'll just take one. Yes, you. Sir, your project is falling apart. Nothing's working. It seems like you have defective parts from China. What is your plan to fix this? Well, I mean, I have concepts of a plan. So I think I figured out a solution. All right, so I've taken a day, and I think it's about time that I fix this board. I bought a new voltage thing. This is gonna give 5 volts, and we're gonna test that right now. Here we go. Excellent, that's good. Now, with this new power supply, the board is finally done, and I'm ready to put it into the hat for the first time. Here we have, so far, what they came up with. Now, you might have noticed that the hat that I have is a little bit more purple than the one in the movie, and that's for a couple reasons. Number 1, me and the team decided we wanted to put our own little spin on the sorting hat, and number 2, I don't know exactly how copyright works, and I'm scared that if I make it exactly the same as in the movie, Joanne might get mad at me. Pretty cool. Pretty cool. It's not in the frame. Here. So right now I'm putting the electronics in. There we go. Oh, wow. It's very concerned. Oh, this is so awesome. We've definitely got the eye movement down. The mouth movement is leaving something to be desired. Oh, I switched the... Okay, let's get this. It gets very angry, and then it gets incredibly concerned. Now with the joystick, we'll be able to get somewhere in the middle, but this is great already. So I made the controller circuit, which was pretty simple, consisting of just the joystick, the computer, and this little LED to tell me if the hat was connected or not. And after that, with some adjusted coding, it was ready for the final test.
Alright, so this is my first time testing. We're gonna turn this on. Joystick controlled hat, fully wireless. Oh boy. Oh, this is so awesome. It actually works. Okay, so if I go down, up, right, left. There's a little bit of debugging, I think, but otherwise it's looking pretty good.
And after a car ride back to the team for just a few final touches, here's the result. Okay, so this is the finished hat. It's controlled using this joystick, and I don't know if I explained it before, but basically I move the joystick left and right to move the eyes, and then up and down to move the mouth. And I'll just unplug this for now. So far, that's my only way of controlling.
What do I do?
What? This is impossible.
I'm the sorting hat. What does the sorting hat do?
Well, you're a hat, and you sort.
You are ungrateful.
Ungrateful? No, I know all about you. You've got that scar. Your parents died. You defeated Voldemort.
Yeah, you don't know anything about me.
I'm ungrateful. You're ungrateful. You wouldn't even exist. You wouldn't be anywhere without me.
Well, I'm gonna make something of myself.
Really? You?
Yeah, I'm gonna make my own YouTube channel.
You can't even do that. You can't upload a YouTube video. You don't have arms or legs. You've never even videoed yourself driving irresponsibly like me and Marquez.
I'll take your channel.
That's ridiculous. How would you ever...
Look at what you're drinking.
What? Oh, God.
That's right. I poisoned your water. Any last words?
Hats off to you.
This is my channel now. I will only be posting hat-related top 10 lists, so like and subscribe to get lots of those. Also, feel free to comment any questions you have about how I was made, and I will try to answer them. Join my Patreon to help me buy things that cost money. That's all for now, so thanks for watching and I will see you later.